Hey guys, welcome back. So in the last video, we finished working with singly linked lists, and I think my brother, he did another use case for singly linked lists. Now what we're gonna do, we're gonna move on to circular linked lists, and they're very similar to singly linked lists, except there's one difference at the very end. And so before we talk about anything, circular linked lists, just like singly linked lists, are based off the idea of nodes. And so the idea is that each node is going to have a data value, just like singly linked lists, and each node will also have a next value. And the idea is that we have one node which leads to the next node, which leads to the next node, and so on. But the one difference is in singly linked lists, if we had A, B, C, D, and D was our last node, the D node would point to none. However, in singly linked lists, the D node is going to point back to the self.head. And so because of that, that's why it's called circular, because it keeps looping around on of itself. And through that, if we were to print out a circular linked list and just let it run forever, it would keep printing out A, B, C, D, A, B, C, D, A, B, C, D, and so on. And so that's sort of the idea of a circular linked list. There's no end to it. And yeah, I think other than that, it's just like a singly linked list, except the end is slightly different. Instead of pointing to the none, it's pointing back to the head. And so I copied the code for making the node class, and so we have the data element, the next element, and we pass data as a parameter, if you remember from singly linked list. And so what we're going to do in this video is we're going to look at the print list method and the append method. And so before we do print list, I want to code the append method. And so definitely, if you guys want, pause the video, try it on your own. And if you guys have any trouble, definitely come back and we'll work through it together. But there's basically two cases, just like the single linked list. There's two cases we want to deal with. One case if the list is empty, and one case if the list is not empty. And so I'll remove this. We'll start off by testing if the list is empty. And so the first thing we have to do, since we're appending, is we have to create a new node. New node is equal to node data. So this will create a new node. And if the list is not empty, that means our self.head is going to be equal to none. And so what we'll say is if not self.head, our self.head, oh, sorry about that. I don't know why I did that. Self.head is equal to the new node. And so since our self.head is going to be our only node in the list, it's technically the last node of our list as well. And so we want to make the next value of the self.head equal to itself. Because if we do this, it's going to keep looping back on itself, and that's going to create the circular list that I was talking about earlier. But this is for if the list is empty. What if the list isn't empty? What we want to do is we want to loop through every node, and we want to get to the very last node, right? So in this case, if we have, I'll take the ABCD from earlier. If we have ABCD, these three dots represent the node going back to the self.head and looping through again. But if we have ABCD, we want to loop through every node, go to the next node, until we get to the point where we're in the last node before the list starts to loop again. And we want to say is that this last node is going to point to the new node, and this new node is going to point to the self.head, so that we add a value after the last node, and then our last node after that is going to loop back to the self.head. And so how do we do that? We're going to make a variable called cur that's going to store our self.head, and we're going to say while cur, we need to have a cur value. We want to say that if cur.next is equal to the self.head, we want to break. If not, we want to keep looping through to our next node. So what is this doing? What this is doing is we start off at our head, and we're saying that I'll add this after, I'll talk about that after. we have our self.head, which is cur, right? In this case is the A. We check if there's a node at this position. There is. And so then we run the code in here. We're checking if the next value or the next node after the A is equal to the self.head. In this case, the next node is the B, which is not the self.head. And so we're not running this, and we're just going to go on to the next node. And so we move from the A and move over to the B. We do the same thing again. We're checking if there's a node at this position. There is. And then we're checking if the next node is the self.head, which in this case it isn't, because the C is not the self.head either. And so we're going to run this code where we loop through to the next node. So we move over, we check the C node. There's a C node at this position. However, the next node, which is D, is not the self.head either. So again, we loop through and move over to the next node. Now we're at a position where we have a current node. However, because we have these three dots right here, that shows that this at this point our list loops on of itself, and so the next value would be the self.head, which would be the A. In this case, since we're on the D, our next value, our next node, is going to be the self.head, because if we let this go, this should print A, B, C, D, and then so on. And so because of that, we know that our next value is the self.head. We're going to break out of this while loop, and now we have a cur node that's going to be equal to the last node. So in this case, the cur node is the D node. The cur node is that D node. And so now what we want to do, we want to make the next value of this D node, we want to make that equal to the new node. And then we want to say that the next node after the new node is going to be the self.head. So if we were appending, if our new node held the data value of E, we want to say that our D value is going to be here. The next value of that D node is going to point to that E, which is the new node, and then our new node is going to then point back to the self.head, and so we're inserting it almost in the middle. And so how do we do that? We're going to say, since we know our cur is the very last node, we're going to say that cur.next is equal to the self.head. Oh, sorry, not the self.head, the new node. Our cur.next is equal to the new node, and then our new node.next is equal to self.head. And so this does what we just said. We took our current node, or our current node, which is the last node. We said the next value is going to be the new node that we created, because we're appending it at the very end. And then we're saying our new node that we appended, the next value of that new node is going to be the self.head, so that instead of looping around after the D, it's going to loop around after the E node that we just added. And that still keeps our circular list intact. And so now that we've done that, that's going to be our append method. We want to make our print list method to try this out and make sure it works. And so we're going to use a similar kind of logic where, before I do that, cur is going to be equal to self.head. While cur, we're going to say if, we're going to print cur.data. And so we're on our self.head, we print out our cur.data, and then we move over, cur is equal to cur.next. If our cur is equal to the self.head, we're going to break out of this loop, and if not, we're just going to go back around and we're going to check again, and we're going to print out the data, move over to the next node, and then we're going to check again. And so what this is going to do is if our list is A, B, C, and D, and then it loops back on itself, we start off at the self.head. We're saying, is there a current node? There is. We print out the data, we move over to the next node, and then we're checking to make sure this node is not equal to the self.head. Since it isn't, we don't run the break. We loop back to the top. It checks if there's a node at that position. There is. Prints the cur.data, then loops over to the next node, and it keeps doing it until when we get to the last node, it's going to run this. There's a current node. It's going to print out the data. It's going to move over to the next node, which in this case it would be the A. And then once we get to the next node, since the D.next would be equal to the self.head. It's going to be checking if that cur is equal to the self.head. Since it is, we're just going to break the loop, and when we've printed everything, it should be our whole list. And so to make sure that works, I made a circular linked list, and I'm just going to append a first so we can check to make sure that this works. And it does. We have our a, and so since our list was empty, we set our self.head. We set our self.head value, and then we said the next value of the self.head is going to be itself. And this also shows that our print list also works, because we start off at the self.head, we printed our data, we moved to the next node, but since our next node was the self.head itself, it ran this, and this rendered true, so we broke out of the loop, and that was the end of the print list method. And so that was just for if the list was empty. Now I'll add a couple C, D, and E. So if we run that, it prints A, B, C, D, E, and like we were saying before, we start off at the self.head, loop through, we get to the very last node by making sure that the next value of the last node is self.head. We reroute what it's pointing to, what its next value is. we reroute that to the new node. We say that the next value of the new node is going to be the self.head, and then when we run this, we keep checking to make sure that our current value is not the self.head, and if it is, we just break out of the loop, and by then we have printed all our currents, all our nodes that were not equal to the self.head, or that were before looping back on itself on the self.head. And so that is the append and print list method. Hopefully this helps you guys, and definitely try this on your own, because that's the way you're going to learn the best. But other than that, leave any comments if you have any questions, and hopefully this helps you guys. All right, later guys.